Welcome to chemistry classes. In this video we are going to discuss about grade 12 chemistry, isolation of metals. Isolation of metals, grade 12 chemistry, last part of this chapter. Okay, so here in this video we have to discuss here purification of metal. Purification of metal from concentrated ore, or we can say refining of metal. Refining of metal or purification of metal from concentrated ore. Refining of metal, there are different steps or different methods to purify metals. Okay, there are several methods to refine metal. Here first one we have to discuss here distillation. Distillation means here metals are easily volatile metal. Compared to impurity, metals are easily volatile metal. Easily volatile metal means you have a mixture of metal and impurity. After strong heating, metal will change to metal vapor. Metal changes to vapor easily. That is easily volatile metal. Metal can change to vapor state very easily. But impurities will stay there. Okay, impurities not change. Only metal will change to metal vapor. Clear? And here example for such type of metals, zinc and mercury. Zinc and mercury are purified by this method, distillation. Okay, so after strong heating, metal will change to metal vapor. This metal vapor, after condensation, we will obtain pure metal and impurities stay back there. This method is called distillation. Example for such type of metal, zinc and mercury. Okay, next one we have to discuss here second method for purification of metal or refining of metal. Here we have to discuss here liquefaction. Liquefaction means here also metal will melt very easily compared to impurity. Metals, they have low melting point. Okay, so metal with impurity will be heat in a sloping surface. In a sloping surface, metal with impurity will be heated. Metal will be melt because it has low melting point, and this liquid metal will be collected down part of the sloping surface, but impurities will be stay back. Okay, this method is called liquefaction. Example for this type of metal, tin. Tin is one example for metal purified by liquefaction. Liquefaction means metal with impurity will be heated. Low melting point. Metals have low melting point and it will melt easily. Okay, this melted metal can be collected on the top part of the sloping surface. Okay, and the impurities will be stay on the top of the surface without any changes. Tin is the example. The previous one distillation, now liquefaction. Distillation, zinc and mercury. Liquefaction, tin. Okay, next one, third method for purification, electrolytic refining. Electrolytic refining, example copper and zinc. Okay, electrolytic refining, example copper and zinc. Okay, so here we will use a simple electrolysis. So we know electrolysis means there will be anode and cathode. Positive electrode will be anode. Okay, and cathode, this is negative electrode cathode, and there will be an electrolyte. Okay, so imagine you want to purify copper, so you have to take impure copper as anode, and the cathode will be thin. Look here, this is thin pure copper. Thin pure copper is cathode and impure copper is anode. Okay, and here electrolyte will be any salt solution of copper. Example, aqueous copper sulfate. Electrolyte will be here metal. We want to purify copper, so electrolyte will be any salt solution of copper. Example, aqueous copper sulfate. Okay, so here we are going to discussing here third method for refining of metal. This is electrolytic refining. Electrolytic refining means simple electrolysis. There is anode, cathode, electrolyte. Okay, electrolyte, this is electrolyte. Okay, so here example for such type of metal, zinc and copper. So here imagine you want to purify copper, so anode will be impure copper, okay, and cathode will be thin pure copper. After passing electricity here, all pure copper will be deposited at cathode. Finally you will get a big pure copper on cathode and impurities will be settled down in the solution. Impure copper is anode, thin pure copper is cathode. After passing electricity, all pure copper will be deposited at cathode. Initially, copper is thin. Finally, we will get a big pure copper at cathode and impurities will be settled down. You understand? So here this is electrolyte. We want to purify copper. So electrolyte will be any salt solution of copper. Example, copper sulfate solution. Clear? Okay, so see here, let us discuss here reaction taking place over here. So here I told you here anode. From anode copper will be dissolved in the solution. Anode made up of copper and impurity. This copper will be dissolved in the solution. So here we can write the reaction here, Cu minus electron and change to Cu2 plus. At anode oxidation takes place. You know these things, you learned this in lower classes. At anode oxidation, copper lose electron and change to Cu2 plus, and this Cu2 plus will be in the solution. From solution, this Cu2 plus will be deposited at cathode and finally we will obtain a pure big copper rod on cathode. Okay, so reaction at cathode, reduction takes place at cathode. Look here in solution there is Cu2 plus. Okay, so this Cu2 plus receive electron and change to Cu, and this Cu will be deposited at cathode. Finally we will obtain pure copper at cathode. Okay, so this is the reaction taking place over here. This is electrolytic refining. Here anode losing electron and oxidation takes place at anode. Cu2 plus will be in the solution. At cathode reduction takes place and Cu2 plus receive electron. Cu will be deposited at cathode. So here we discuss three important methods for refining. First one distillation, zinc and mercury is example. Second one liquefaction, tin is example for liquefaction. Third one we discuss electrolytic refining, simple electrolysis, zinc and copper is example. So here zinc is example for two processes. First one distillation, second one electrolytic refining. Okay, next one here, next method here, zone refining. So here we discuss three methods to purify metal: distillation, liquefaction, electrolytic refining. Fourth method, we have fourth method, it is zone refining. Zone refining, this method used to purify semiconductor, or you can say metalloids. Okay, metalloids such as boron, silicon, germanium. Okay, boron, silicon, germanium, gallium, indium, and this method helps to make semiconductor. Okay, so here zone refining, here mainly metalloids are here. Zone refining related to metalloid, and zone refining helps to make semiconductor. Okay, example for elements to purify this method: boron, silicon, germanium, indium, gallium. Okay, these are the elements purified by this method. The basic principle for this method: impurities will melt easily and not metal. Here in these two cases we discuss metal can change to vapor easily, or here metal will change to melt, or metal has low melting point. But here zone refining mean impurities, they have low melting point and it melt very easily. Okay. And here there is a circular, you can see here in this figure, you can see here there is a circular mobile heater fixed at one end. Okay, there is a circular mobile heater fixed on the on one end of impure metal rod. Okay, and this heater will be moving from one end to another end. And we discuss impurity, they have low melting point and it will change to liquid state or it will melt and it move with the heater, it will move with heater from one end to another end and it helps to purify this metal rod. Okay, so here we discuss zone refining. Zone refining, it helps to purify metalloids. Okay, this method helps to make semiconductor elements. Example for elements purifying by this method: boron, silicon, germanium, gallium, indium. Okay, and here the basic principle here, impurities will melt with a low melting point, metals have high melting point. And there is a circular mobile heater, it fixed one end of the impure metal, okay, and heating one end of the metal rod, and impurities will be melt and heater will be moving from one end to another end and impurities will move along with the heater. Okay, finally we will obtain pure metal rod. We have to repeat this process several times, okay, and all impurities will reach one end of the metal rod, rest of the part we will get pure metal. Okay, this is zone refining. So zone refining, you have to remember boron, silicon, germanium, gallium, indium. Okay, and the semiconductor zone refining. Clear? Okay, next one we have to discuss here vapor phase refining. We are talking here different methods for refining of metal. We already discussed 3 methods to refine metal. Okay, next one we have to discuss here 4th method. This 4th method called vapor phase refining. In vapor phase refining, again there are 2 methods. Okay, so here already we discussed 3 methods for refining of metal, which are 3 methods: distillation, liquefaction and zone refining, electrolytic refining. We discussed 4 methods. Okay, this is 5th method. 4 methods already we discussed: distillation, liquefaction, electrolytic refining, zone refining. Next one, 5th method here, vapor phase refining. Vapor phase refining again classified 2. Okay, first one, Mons process. Mons process. Second one, Van Arkel process. Mons process and Van Arkel method. Okay, so first one we have to discuss here Mons process. Mons process. This method used to purify nickel. So you have to remember method and which metal purify using this method. Mons process, nickel. Okay, so here vapor phase refining mean here metal will be metal first convert or metal will be heat with other suitable compound and it will change to volatile compound. Okay, then this volatile compound again after strong heating it will decompose. So these are the 2 methods involved in vapor phase refining. So vapor phase refining, it involved 2 methods. Okay, so these are the 2 methods. Okay, which are 2 methods: Mons process and Van Arkel process. Both process involve this procedure. Which are the procedure? Here first, metal compound. Metal after strong heating it will convert into volatile compound. This volatile compound against heating higher temperature it will decompose to pure metal. Okay, so these are the two procedures involved in vapor phase refining. So here we can discuss here next Mons process. Mons process used to purify nickel. Here in this method, in Mons process, nickel will be heat very strongly in a stream of carbon monoxide. Okay, nickel will be heated strongly in presence of carbon monoxide and it form tetracarbonyl nickel. This tetracarbonyl nickel again after strong heating more than 450 Kelvin, it will change to pure nickel and carbon monoxide. So it involved two. First one, impure nickel. This is impure nickel. Finally you will get pure nickel. That's why we are doing this one. Okay, here nickel means not only nickel, there are impurity. Nickel with impurity will be heated in a stream of carbon monoxide around 330 Kelvin. Okay, then it formed tetracarbonyl nickel again after strong heating more than 450 Kelvin, it produced pure nickel and carbon monoxide. This is Mons process. Mons process nickel. Remember this. Okay. Next one we can discuss here Van Arkel process. So vapor phase refining, it involved two methods, Mons process and Van Arkel method. Now we can discuss here Van Arkel method. Van Arkel method, here two names. So there will be two metal. You can remember like that. Van Arkel method, zirconium and titanium. Two method, two name. Van Arkel method, zirconium and titanium. Here also this impure metal will change to a compound. This compound after strong heating, it will decompose to pure metal. Okay, so look here metal will be heat strongly in presence of iodide and it form metal iodide. Here Mons process, nickel heated with carbon monoxide, but Van Arkel method, here zirconium or titanium will be heat with iodine very strongly. Okay, zirconium and iodine heated, or zirconium, you can choose zirconium or titanium, heating very strongly in presence of iodine, it form metal iodide. Okay, this metal iodide will be decomposed to pure metal, pure zirconium or pure titanium and iodine. Okay, at very high temperature. Okay, at very high temperature, this decomposition takes place in presence of tungsten filament. We will use tungsten filament. Okay, we will use electric heater, or we will use electricity and we will pass electricity through tungsten filament. Okay, in presence of tungsten filament, this metal iodide will be decomposed to pure metal and iodine. Okay, so here we discuss vapor phase refining. Vapor phase defining, it involved two, okay, Mons process and here Van Arkel method. Mons process, it helps to purify nickel. Van Arkel method, it helps to purify titanium and zirconium. Clear? Okay, next method for purification of metal, chromatographic method. We discussed different methods to purify metal. Here last method, chromatographic method. Chromatography. Here this method depends on a mixture. We know mixture which contain different type of components. These different components will be adsorbed differently in a surface. Okay, this is the basic principle. We know mixture which contain different type of components, and these different components will be adsorbed by a adsorbent. Okay, this adsorption will be different extent. Some of the component will be adsorbed more, and some of the component will be adsorbed different less amount. Okay, so here we have a mixture. This mixture will be passed through a surface. okay, and a gaseous medium or liquid medium will be pushed this mixture through a surface, okay, and this surface will be absorb different components of mixture in different extent, and this absorbed material can be separated by suitable solvent. This is chromatographic method. Okay, so here we have a mixture. This mixture will be passed through a surface. How can we pass this mixture? This mixture will be pushed by a gaseous medium or liquid medium. Okay, and here this surface will be absorbed. This mixture, different components of mixture will be absorbed by surface in different extent, and it helps to separate the mixture. Okay, this adsorbed material can be separated by suitable solvent. Clear? There are different type of chromatographic experiment. Thin layer chromatography. We can use different type of chromatography. Thin layer chromatography, high pressure liquid chromatography, gaseous chromatography. These are the different type of chromatography. Okay, so this is chromatographic method. Remember, this is the basic principle. Different components of a mixture absorb in different extent. Clear? Okay, so these are the different methods to purify metals. We discussed different method: liquefaction, distillation, electrolytic method, chromatographic method, then vapor phase method. We discussed different methods. These are the different methods to purify metal. Okay, next one we have to discuss last part of this chapter, some important uses of metals. Okay, we know we have wide uses for the metals. Now in the world we use metals in all purpose. We discussing here some important uses only. Okay, so here first one, aluminium used to make aeroplane parts, aircraft parts. Okay, aluminium used to make aeroplane parts because aluminium has low density, also it is very hard. That's why aluminium used to make aircraft part, or you can say aeroplane parts. Okay, after that we know aluminium, it is metal. Aluminium is malleable. Malleable means aluminium can be converted into thin wire. Also aluminium is good conductor of electricity. That's why aluminium used to make electric cables. Okay, also aluminium is aluminium is ductile. Ductile means we can convert metal to thin wire. Okay, metal can be converted into thin wire. That property called ductile. Okay, also here aluminium is malleable. We know metals are malleable. Malleable means metal can change to metal sheet, thin metal sheet. That's also metals. Also metals such as aluminium is good conductor of heat. That's why aluminium used to make cooking pot. Aluminium used to make cooking pot because it is malleable. Also it is good conductor of heat. Aluminium used to make electric cables because it is ductile. Also it is good conductor of electricity. Next one we can discuss here, copper. Similarly copper used to make cooking pot because it is malleable. Also it is good conductor of heat. Copper used to make electric cables. Okay, electric cables because copper is similarly same like aluminium. Copper also ductile, also good conductor of electricity. That's why it used to make electric cables, electric wire. Okay, and copper used to make different type of alloy, brass, bronze. These are some example for alloy made by copper. Copper used to make brass which contain copper and zinc. 60% copper and 40% zinc, that is brass. Bronze mean copper and tin. Okay, bronze mean it contain copper and tin. Clear? Also zinc, another metal, important metal, zinc. Zinc used in batteries, different type of batteries made by zinc. Also galvanizing. Galvanizing means we can prevent rusting of iron using zinc. This process is called galvanizing. So zinc used in galvanizing. Also zinc used to make one important alloy. It is called German silver. German silver, copper, zinc, nickel. Copper and zinc, brass. Copper, zinc, nickel, German silver. Okay, so these are the different important uses of metals. Okay, and these are the things we have to discuss in this video. You can review the video once again. So thank you for watching this channel.